Hello again. You may recall in a previous lecture we talked about relative position, and we learned that the position of some point A with respect to B was equal to the position of A with respect to some fixed origin, wherever that might be, minus the position of B with respect to the same position, the same origin. Right? But now what we want to do is take derivatives with respect to time. So if I take the derivative of R, A slash B, the position of A with respect to B, that's equal to the derivative with respect to time of the position of A, right, minus the derivative with respect to time of the position of B. Right? So when I take the derivative of a difference, I just take the difference of the derivatives. Well, this is then the velocity of position A with respect to B, if there's some movement going on, which is the velocity of A with respect to some origin, minus the velocity of B with respect to some origin. So we want to take a look at relative velocity now, which is what we're talking about here. And we're going to start off just looking in one dimension, kind of keep things simple. And so here's what I've got. I've got a railroad car moving down a track at 7 meters per second. There's somebody over here, Pat, and Pat is stationary on the track. Pat is not moving. So Pat would be a good origin, if you will, because Pat is stationary. Right? It doesn't have to be, but that makes life a lot easier. Pat will be our origin. All right, then on this cart, Mel is moving to the right at 2 meters per second. So I'm going to say the velocity of Mel is equal to 2 meters per second. But that, I've got to be really careful with that because that's the velocity of Mel with respect to the car. In other words, Mel is walking on the car 2 meters per second to the right. Mel is walking on the car 2 meters per second to the right. So this is the velocity of Mel with respect to the car. In a similar way, Nelson is moving to the left on the car. So Nelson has a velocity of 3 meters per second, but negative because it's to the left. So Nelson has a velocity of 3 meters per second, but that's with respect to the car. So I need to subscript that with respect to the car. All right, because I want the car to be a moving thing. I'm not going to use that as the origin. I could use that as the origin, and maybe that's something I'll talk about here in a little while. But let's just leave the origin as Pat. All right? So I have the velocity of Mel with respect to the car and the velocity of Nelson with respect to the car. And then the car is moving at 7 meters per second down the track. So what I might be interested in is the velocity of Mel with respect to Pat. So I'm interested in the velocity of Mel with respect to Pat. Now let's forget subscript notation for a second. Let's just argue it out. So Pat sees the car moving at 7 meters per second to the right. And Mel is moving to the right on the car at 2 meters per second. So what Pat's going to see is 2 meters per second for Mel with respect to the car, plus the car is moving also in the same direction to the right at 7 meters per second. So what am I going to get here? I'm going to get 2 meters per second, I hat, plus 7 meters per second, I hat. And so Pat is seeing Mel move towards Pat at 9 meters per second in the I hat direction. Right? So 2 meters per second, faster than the car because it's on the car, plus the speed of the car. That makes a lot of sense, I hope. Right? But this is going to be the velocity of Mel with respect to the car plus the velocity of the car, and I've got it right here, 7 meters per second. That's with respect to some stationary origin, but I said that the origin is Pat. Right? Now, sometimes when we talk about the origin, we don't give it a subscript. I want to leave them in there here for now. But keep in mind, I don't need to write them that way. I'd like to, but a lot of books won't. They'll just leave it as the velocity of Mel with respect to the origin, so they might have that as just V sub m. Right? I prefer not to do that here, but know that you're going to see that in textbooks. Notice when I look at this is a vector quantity, if I look at the subscript, I've got m over c, I've got c over p, and my final result is m over p. So it's almost like the c's canceled in multiplication. So as I look at the subscripts, treat them like fractions. When I add them, then multiply the fractions. And you eliminate the c's, and you get m over p, which is Mel with respect to Pat. Right? And that's the kind of the neat way of looking at how I'm going to do this as far as the subscripts go, right? Whenever I'm adding them together. Let's change things just a little bit though. I talked about let's make the car the origin, right? And I want to know what's the velocity of Mel with respect to Pat. But the car is now the origin. And so this might be, let me go ahead and erase this. I'm going to erase that too. This might be the velocity of Mel with respect to that origin. So I'm just going to leave it. Well, let me put a C in. Velocity of Mel with respect to the origin, which is the cart. But I also want to add in the velocity of the cart with respect to Pat. Pretty much just what I just now wrote. But if I want to say, hey, let's make the cart the origin, right? Let's make the car the origin. How am I going to do this? Well, I might write this way. The origin is the car, so let me just write Vm like a book would. Vm is the velocity of Mel with respect to that origin. Then I need, this is the origin right here, so how am I going to do this? When I switch the P and the C, the velocity of the cart with respect to Pat, I might want to write this, let me write it this way, as the velocity of Pat with respect to the car. Right? But the velocity of the car is looking at Pat. Pat's moving to the left as far as the car is concerned. Right? Because Pat's moving towards the car, right? This direction. So I've switched the subscript, but Pat's moving the other direction, so there's a minus sign in here. So the velocity of Pat with respect to the car, but again, the car is the origin, so let's get rid of that. Because the car is the origin. So Vm over P is Vm minus Vp, but I've got that right here. Right? It's the same thing right here. So I can take the velocity of Mel with respect to the origin, in this case the car, minus the velocity of Pat with respect to the origin. And I'm going to get 2 meters per second I hat minus the velocity of Pat. But if the car is moving at 7 meters per second to the right, with respect to the railroad track, Pat is moving 7 meters per second to the left as far as the car is concerned. Right? So if I have Bobby sitting here on the car, they see Pat moving towards them, which towards them is in that direction. Right? So this is minus 7 meters per second I hat. And so what do I get? I get 9 meters per second I hat, which is exactly what I had earlier. Same value. So it doesn't really matter who's the origin and who's not. What matters is pick an origin, stick with it for the problem, and then use it consistently throughout that problem, and you'll be fine. The other thing to keep in mind is this reduction of the subscripting. Okay, the reduction of the subscripting. Personally, if I'm doing this problem, I don't want to do it this way. I want to do it the previous method where I had the railroad car moving on the origin, and the origin was Pat. In other words, the object I know is stationary. Know is a relative term again, though. It's all relative, right? I'm going to say Pat is stationary, make that the origin. Then I feel a little bit warmer and fuzzier about it. Motion is all relative. You think I'm standing here not moving, but the earth is rotating, so I'm moving. And the earth goes around the sun, so I'm moving. And then the sun goes around the center of the galaxy. Don't get me started, right? So we can go a long ways with all of that. There's your relative motion. There's your relative velocity. Keep it simple to understand it here in one dimension, and then in the next example, in a future example, we'll do it in 2 dimensions. All right, any questions on this? Be sure to leave them in the comments. Thank you.